Hello, beautiful people. Let's go ahead and do some smoke. I know that is not pretty realistic. Come on, go outside and take your reference. And we are not going to do some realistic stuff here. Yeah, maybe a little bit puffy, but I swear I saw something like that. We're going to control it. We're going to learn how to control it. And I learned it just recently. I want to share with you, so maybe that could be useful. So let's control different masks. And the main idea for that part was like to have this very disturbance motion at the start. And of course you could have very straight motion, and then just like a wind is the smoke is going to dissipate. I want to wind it out, something like that. So this is different masks we are going to create with gas solvers, and the main driver is this one. This one is the position, as you could see that as it reached this yellow part is a 1 meter or 2 maybe. It goes to the side and has most influence. This one is a speed mask for this volume, and this is cool based on the Rebelway tutorial. I will link that as usual in the description below. And this is calculating the velocity and gradient and all that stuff, so you could see that we have a leading part of this smoke, and this means that we are affecting only the leading part of the smoke. Based on this field mask, you could create whatever you want. You could disturb it, dissipate it more, or have some additional gravity or turbulence, anything you want. Let's jump in. I think it should be short and fun, and let's do that. Okay, I prepare one scene. So this is the scene we have before. And considering you already know how to do that, okay? This is a simple tube. The tube is transformed and rotate somehow with expressions. It is going up, so it fits in the tube smoke. That is like our pyro source. With these settings, it will create some initial, you could turn that here, smoke, burn, coil, fuel, and so on, and particle separation. It will create initial two fields, density and temperature, and we'll go ahead and manipulate that with some attribute adjust float that will multiply the density, and then we just need to rasterize it, temperature and density. Both are here. We might velocity blur, but we don't have any velocity, but we have normalize by clamping coverage the density from 0 to 1. Okay, and on this side it's like collider VDB we'll use in this one, and it's just a simple object I downloaded from the online that is clipping the object. Then I created a cube, I union it, so it's like filling union solid piece. Then I create a VDB from that, and that is a source for our out VDB collider. I will copy that and paste inside. So one thing I would love to have is copying this guy from the main tutorial, so I'm not going to create that and paste it here. Out, let it be out without the number. And yeah, I think volume source, last thing I need to do. So this is a very basic stuff. Sourcing, as you can see, this is second from the last, and sourcing is the first content geometry. I need to initialize the source smoke. I need to enlarge fields to constrain source contains, and the static object is going to be use volume collision, proxy volume. That is this one. So I need to copy that in this case and copy and paste. And you could visualize that by clicking this collide show guides. I don't need to see that, so yeah, and that is it. That is pretty our simulation. What I want to have next, I want to affect that with some gas fields. And here, the idea here, I want to manipulate the motion of our smoke, because yeah, we have it. We have our pretty famous and known mushroom shape of the smoke. And if that is what you need, great. But I want something more than that. And the general way is to go here, and this shape, you have the general effect you could do with the noise, dissipation, disturbance, turbulence, radiant, and wind. And here you have fine control over that. If you click, for example, on the turbulence, the tab will allow you to control that, what field you will affect, control field, for example, density, remap that, and it's pretty powerful as well. But we are going to create, in our case, what I want to do is like I want to have a mask over the density, and I want to remap this mask in the position and affect that like the wind blowing away only the upper part of that. In order to do that, we'll use the gas node. This node, it's like a lot of that. It's low level connection to the and low level effect, and we have a lot of that. And we start with creating a field. So let's create a gas match field. This one will allow you to create like a field, like a box. And let's start to do that, and I will explain as I go. So the field I'm going to create is mask pose. This is like, you could name it whatever you want, but reference field, you need to specify the existing one. In this case, you could go to the geometry spreadsheet, smoke object, and you could see that you have all of this. Density, divergence, flame, and pressure, and so on, and temperature. You could like create your field based on this that you already have. And in this case, we created a density based on the density. So this white thing is the density one. Pay attention to the scalar, vector, metrics, and so on. You could always use same as reference. That is better, I think. And the next thing, like, okay, if you update your simulation, it's okay, it has something. I think I have a turbulence, let's turn that off. Rising smoke, and you have already this mask pose. For now it's empty, but you could use that. First you could of course use a gas analyze node. And this one will allow you to analyze and calculate something from here. For example, the length of the vector of the velocity, and that will going to be a speed. And we could use a gas wrangle, gas field wrangle. In our case, we could use this one, and we could remap it. So if we type something like gas pose, mask pose is equal to something. For example, we want to remap a position on the Y from 1 to 2, from 0 to 1. So as an output, based on the density field, based on the position, you will have a mask called mask pose. And you specify that this mask should be from 0 to 1 based on the position of the smoke. And the next step you could do in one wrangle, but let's create another one just to be visually separated. And we could call it something like apply velocity. And this way you could call a velocity. So I show you that you could use all these wrangles and VOPs to manipulate these fields. And that is pretty much the same in the SOP level. So if you know how to do that, shouldn't be a problem. And in this case, I want to apply this by X, different directions. And let's see what we got. Pretty quick, we got something because we just hardcore the position. But if we add that to the numbers we already have, we could see that everything is applied to everything. Okay, so now we just need to apply our mask, which should be multiplication by the mask pose. And let me see what we got. So from 0 to 1 we have nothing, because we have from 1 to 2. And then after 1 meter we should have some motion to the side. And that is exactly what I want to achieve. This is like the tube or smoke tube. And when the smoke rises, first it has like this velocity on the top. Of course, you need to tweak that a lot more to have some realistic effect, but this is the core of that. And after some period of time, like a wind, strong wind, applied to the smoke, and the density goes less than the source, and it's flying away. In this case, let's do 0.5. And another thing, like, of course, you want to have a low-res sim and you want to visualize it somehow. And let's create a DOP import output node. And then we could choose the smoke, and you have these presets. So choose the smoke. We don't need any temperature or rest. Let's keep only these three. And in this case, we need to add one more. Oh, sorry about that. No, this one. This should be invisible. And let's specify it as a mask pose. And the next node would be volume visualizer. So this node will allow you to map your density to a different color. So you choose the density and you choose your mask pose effect. And in this case, let's choose something like Inferno. Let's change the dark color to, for example, green. So we know that 0 is green. And if we go here, you could see that it shows our mask. Let's go ahead and see what we got. Okay, let's stop it here. So, and this is very cool way to, let's delete this one to be a little bit more vibrant, and let's do a green. And this is cool way to see how your mask is affecting your smoke. So in this case, we haven't ever reached the full potential of our mask. This is bright yellow. Let's turn it a bit here. But as we rise, as you could see, the mask is going to change the different color. I still want to have it blue, for example, to have it more purple, and maybe just to see it better, something like that. Let's not apply this strong effect. Let's do less of that and see what we got. And now let's move a little bit faster, and as you can imagine, this could be less of that, and this field that we have just created could be applied to everything. So that means that if we create another merge, let's delete it, let's connect it here, and let's do another one. So we created and manipulated the mask, and now we could use something like gas turbulence. And remember, from left to right, so we need to, from top to bottom, we need to create this field first, and then we apply something to that. And we could go, if we go here under the control field, you could use the same mask pose at the control field of this turbulence. So let's disconnect this apply velocity. So let's see what we got about that. And yeah, it's not perfect, I think, because of this different remapping thing. And if we go here, let me check. Yeah, now it's a bit better. And this control influence, it's like 0, it has influence to everything. And 1, over this control mix 1, it has more of strong effect. But we don't want to be super precise, that's why not to do a little bit of influence to everything. But as you could see, first it has nothing, and at some point turbulence is kick in and try to destroy our shape, mushroom shape. And that is exactly what we need. For example, for this first one, I want a big of a scale, or I mean, because swirl size bigger and less of a scale. Let's do that. Let's back our velocity and let's build on top of that, and let's create 2 more masks which we could use, and that will be our effect. And the logic behind that will be the same, but you will see that how we could apply that. So let's do this first one. Maybe you want to create another field, and now it starts to be a little bit interesting. So let's do a mask speed. It could be again a same reference, and a reference field could be a density, but now we could use a gas analyze for that part, and mask speed, and the source field will be velocity. Okay, and I think in this case we need to use a vector. Oh no, because we have a speed, so it could be a scalar, float means, and we could calculate a length. So these two is going together. We create a mask speed, again, as the same as the density, and then we calculate the length base of the velocity, which means like a length of the vector. And if we use another turbulence, and we have mask speed, and we have remap it, the faster the velocity will get, the more effect you should expect from this turbulence. Okay, but this time we need a smaller size and a bit of more of effect. That means that right from the start that will destroy our mushroom shape, and that is cool. That is exactly what I need. Let's start again. Let's see what we got. Yeah, maybe not that strong. Again, we need to tweak back and forth, but overall that is great. That is great of an effect. And combining with these two, and maybe again creating another visualization. This time I will go a little bit faster and not explain every step I'm doing. So we need to change that to mask speed, and of course we need to add another field here and call it mask speed. And you could see that, okay, this is our field. So the main effect will occur when it's yellow, right there. And as the smoke is getting calmer, changing the speed, and under the visualization we have diffuse range from 0 to 1, and if we go from 0 to 2, that is more of a range of the motion. Okay, let's go here, and this way we could say that control makes it from 0 to 2, and that will affect only the most fast part of this smoke. Yeah, that is the level of control I'm after. We still have this though mushroom field. Let's break it a little bit more. Let's give it a little bit more of grain, and maybe under the speed I will use another node called gas disturb. Small noise on the surface of your, as you could see, like the most common surface of your smoke is affected by this noise, but of course this strength is way too strong. We have to, this strength is the level of control, and like the reference scale, it means how big that will be. I maybe want a bit bigger in this case, I'm not sure for now, but again, maybe 2 is okay, but strength could be 0.8 in this case. We have very small scale simulation, but we don't want to occur that everywhere. Again, we could use a control, we could use a density, so the less density, the more effect, or the more density, it's up to you. But I will use a mask speed. and we know that from 0 to 2 is okay, and maybe only the fastest of the density of our smoke will get this disturbance. And let me show that. I don't see nothing, so maybe go back to 1 and maybe something more of the effect. Yeah, and smoke simulation is something like that. As you could see, you go back and forth. Maybe we change and we'll use, like, when it's up to 0, it has an effect. So not the fastest but slower density have the effect. I like it. But of course we could change it to 2. Now we need to change the influence strength to 0.8. Yeah, it's a bit back and forth, but you know what? Let's do that. I see that it's not that mushroomy. I could lower that a bit more, but in this case it's cool. And when I will increase the sim resolution, it will look good. Okay, we have 2 of that mask. We have a speed and we have a mask position. And let's go ahead and let's create this third one, which is great, and that is based on our Rebelway tutorials. And that will give you only the leading parts of this smoke to have the influence to. And at this point we have something like that. I went ahead and tweak it a bit, tweak into the numbers, but to me it's looking cool. And let's go and create the most cool mask ever created on this. It's a bit more complicated than that, but the logic behind that is the same. We have some fields and we want to isolate only the leading part of this. Okay, let's go back to our DOP network. Let's go here and let's see what we got. For the next mask, we need a few things, quite a few things. So I will create that here. Gas match field. And basically we want 2 fields. First will be our mask gradient. And the field will be a density, and that should be a scalar field. And this one, I will update this one. So it has the density, the area of the density of our field, and it's just empty for now. And the next one, I will just copy this one. I want to create a field called gradient, just a gradient. Maybe I'm going to create this reference, the velocity field, and for the next reading I will change that to vector because I want to calculate the gradient. And another one is gas analysis. And this guy will calculate our gradient, this field, which is velocity, which is vector. Let me see what we got. So I want to calculate a grad field based on the velocity in this case, and I want to calculate a gradient. And let's do a first frame, and it's giving me the error. For the gradient analysis, we need a source as a vector, right? And we need to analyze based on the density. It's like the density in this case is the volume, and we want to calculate the gradient, and I would imagine the gradient is something like a normal vectors of your geometry, but in this case the normals of your density. And this way we have no arrows. And the cool about that okay, we calculate that and we could create a gas warp, but I will use a gas field triangle again, just simpler to me to think about. We will like separate visually these parts, okay, just to have understanding that this is a mask of the position, and this is a speed, and this is another mask. Obviously you want to create a merge for everything, but And for now, it's pretty complex. Yeah, it's cool. So for this part, we need two vectors, and we need to calculate a dot product between these two vectors. Okay, next thing, I will create a float d for dot product, and I'm going to calculate a dot product of two vectors, normalized vectors, as you could see. That would be gradient and v, and that will give me the direction. So if both of that vectors are in the same direction, for example here, velocity as a speed, the direction is there, and gradient is a normal of that point is the same direction, that will give me 1. And if the direction is opposite, that will give me -1. So the result of this dot product is -1 to 1. And everything in between will be from 0 to these numbers. So knowing that, I will go ahead and feed that number. I could use a feed 1, 1 to 0 to 1. That will feed numbers between -1 and 1 to 0 to 1. So somehow I normalize that. And the last thing, I will update our mask gradient. And remember, that is our field that we have created here, mask gradient based on density, and is float field. And I will say something like channel ramp. The name would be mask. And the source for this will be, I think, D, right? So now no error. And we did something, but we need to visualize that and estimate if that is right or wrong. Let's go ahead and create another visualization, and see what we got. Well, we have nothing, right? First, I want from 0 to 1. And let's check what we have done. Oh, okay. We didn't create the ramp itself. And in this case, I want something like Bezier or B-spline, something like that. And okay, let's go back, and we have something. Exactly what I need. So I just need this, eliminated this part of the leading edge, but I want the opposite of that. So go back and just simply click this button. That will invert our ramp, and that will give me this result. And this is cool. This is the most satisfying mask I have ever created for the smoke. So that means that we could influence only this part, only this leading edge of the smoke. This is very fine control, but we have it. Again, the next part would be like, I'm not sure. Let's try a gas field triangle. And we want to control that with divergence field, for example. So let's add to our divergence field based on this mask. When the number is positive, the volume will increase in the space, and when the value is minus, below the 0, that will shrink. So let me see what we got. And indeed, we have this puffy motion for the leading edge, and that will only affect the edge of this motion, as you could see. And this is cool, right? And again, you could disturb these edges, you could turbulence it, and yeah. The last thing for this part, I would say I would like to pyro post process. This node will allow you to organize your scene better. For example, you could convert your volume to VDB. That will save you a lot of space. You could convert that to 16-bit float instead of 32. Convert to VDB is also very useful when you render that with Arnold, for example, because as far as I'm concerned, the Arnold will use a VDB. You could do it by yourself, like connecting these nodes, but in this case, we have everything in one. You could call volume, velocity, because you don't need to keep that as dense as your density field, and you could do this velocity all in one and smaller than your main field. What else? And yeah. And now you are ready for your file cache. So I will go ahead and increase the resolution, and I will go ahead and render it, and I'll show you the next part when it's rendered and everything is. But for now, hope that it was useful and you grab the file for free for this tutorial. That will include all the notes and all the VEX I've done. Just have fun. I will link that in the description below. Just a side note. What else could be done in this world but be useful and to bring some joy and fitness to the life of people learning the Houdini? Bye bye till the next one.